This video will work through problem 8.2 from Gapenski's Healthcare Finance, 6th edition. In problem 8.2, we're presented with the same static and actual budgets as we've been working with in problem 8.1, but we're now introduced, we have two flex budgets, one that is titled flex enrollment / utilization, and the other which is called flex enrollment. To understand this or to get some insight into this problem, you need to go back to page 291, and there's a note at the bottom of the page that provides the formulas for volume variance under this arrangement, as well as enrollment and utilization variance. So we're going to use those formulas here to do this problem. But in answering part A, which is what does this tell you about the nature of the patients, are they capitated or fee-for-service, the answer is they must be both. And why do I know that they're both? Well, with capitated patients, my reimbursement comes from the per member per month reimbursement that I get from the insurance company for each individual that I agree to take on and to cover their lives. And then so I know if I see something about enrollment, I know that I'm dealing with a capitated capitated patients. And then utilization, since this is given as revenues, since utilization is not relevant for calculating revenues for capitated patients, because I don't get reimbursed based on the amount of utilization. My costs are based on utilization, but not my revenues, right? My revenues just come from the number of people enrolled times the per member per month price that I get paid. But utilization, a utilization number implies that I also have fee-for-service patients, because my revenues for fee-for-service patients are entirely driven by utilization. So in this case, because we see a flex that includes both enrollment and utilization, we can assume that our patient population is a mix of capitated and fee-for-service patients. Okay. So what do these numbers mean? Well, the static still breaks down into this is my pro forma, right? My my plan, right? My budget for the year, my expectations. So I have some expected price, and some expected volume. But because I'm dealing with both enrollment or capitated and fee-for-service patients, my volume is really two different things. It is the utilization amount, or the number of visits that I'm going to have for my fee-for-service patients, so utilization, my expected utilization, and then the number of enrollees that I expect, so my capitated enrollment. Those two things multiplied by the average price per fee-for-service patient and the average PMPM get me my static budget. Over here, again, in the same vein, my actual, of course, is what my actual per member per month reimbursement was, as well as my reimbursement per visit. That becomes my actual price. And then my volume breaks down, again, just like on the static side, it breaks down into my actual utilization and my actual enrollments. Those are what drives my actual revenues. Now, where things get a little more complex is the flex, right? So the flex, if you just ignore this flex enrollment for a moment, this flex is just like the flex we did in 8.1, where we take the expected price, right, from the static. We take the expected price, and then we take the actual volume from the actual, so that this flex account allows us to do our overall volume variance, and then comparing this flex account to the actual allows us to do our overall price variance. But because we have two different patient groups that we're working with, we need a second flex that allows us to break out the impact of of the capitated patients from the fee-for-service patients. And so this flex, whereas the main flex gives us our actual utilization and our actual enrollment. So the actuals for both this flex, the flex enrollment, uses the expected utilization, but allows the enrollment to be actual to vary. So if we compare this flex to the static, the only thing that's changing is the effect of the enrollment volume, right? We're holding the prices constant. We're holding the utilization expectation constant. So we're holding the expected prices, so that's the same. We're holding the expected utilization the same. So the only difference between this number and this number is enrollment. And so it's the effect of actual enrollment versus expected enrollment causes us to have a difference between the static and the flex enrollment. So the difference here is entirely the result of the difference between what we thought we were going to get for enrollees and what we actually got for enrollees. So that's going to generate our enrollment variance. So we'll get to that in just a moment. And then to get our utilization, to isolate the effects of a variance in our utilization, so the effect of our change in our fee for service, we compare the two flexes, right? Because we hold the expected price and expected price, and the only thing that varies, remember here, right, comparing between these two, well, we're holding enrollment constant, but we're allowing the utilization to vary. So the only difference between these two revenue numbers is the amount of change in utilization. So this becomes our utilization variance and tells us how much, what the impact was of the change in utilization from what we thought it would be to what it actually was. Okay, so I'm going to now work through the actual questions in Part B. So the answer to Part A is, we know that this clinic serves both capitated patients because we're concerned with enrollment, but also fee-for-service patients because we're concerned with utilization. And again, because this is revenue, right, not cost, utilization is irrelevant for our capitated patients. So if you see revenues being expressed as utilization, then you know you're talking about fee-for-service patients. So that's the hint that you can tell that you're dealing with fee-for-service patients in this case. Okay, so let's start to answer the different parts of the problem for Part B. Okay, so the first part of B asks us to calculate the revenue variance. All right, so revenue variance is equal to the revenue actual minus the revenue static, right? Because it is our actual revenue that we earned over the course of the year, or whatever the relevant period is, minus the amount that we expected to earn. And the reason we do actual minus static is we are hoping that the actual revenue is bigger than the static revenue. And if that's the case, right, if we earn 100 when we thought we were going to earn 80, we would have 100 minus 80 would be plus 20. So the book wants you to express your variances as if the variance is positive, then that's a positive outcome, meaning you earned more than you thought you would earn. If you did it the other way around, right, if you had revenue static minus revenue actual, and you had revenue static of 80 and actual of 100, and you did 80 minus 100, you'd have minus 20. And that's still a variance, but it winds up expressing it as a negative, and that gets confusing because you have a negative 20 revenue variance. It sounds like that's a bad thing, when in fact it would be a good thing if you had it set up such that it was static minus actual. So revenue variance, just like before, is revenue actual, which is 300, minus revenue static, which is 425. So in this case, we have a minus 125 revenue variance, which is in fact bad, right? Because we thought we were going to earn 425,000 in revenues, and we actually earned 300,000 in revenues. So we know that we missed our target by 125,000. So revenue variance breaks down into volume variance and price variance, right? So revenue variance has to equal price variance plus volume variance. And so we'll do each of those. So volume variance is, let's go back here. If we ignore enrollment flex for the moment, okay, we'll use it in just a second when we get to the more granular enrollment and utilization variances. But if we ignore the flex enrollment for now and we treat the flex enrollment / utilization as the same as the flex variance that we used in problem 8.1, and because it completely captures all of the volume variance, right? So this is just like 8.1's flex, where it completely captures all of the volume variance. If we compare to get volume variance, right? So ignoring this part now, what's the difference between the static and the flex? Well, the price is the same. The volumes are varied. So we are seeing the difference between the flex and the static is the result of changing the volume from the expected to the actual. So our volume variance is going to be our flex, 200, minus our static, 425. So I should have written that. That's our revenue flex minus revenue static, right? This was what we expected. This is what we actually, well, this is what we would have gotten had we earned the expected price and had the actual volume. So that is a 200 minus 425 is a negative 225. Okay. And then price variance. We're looking for, again, we're going to ignore the flex enrollment for now. And we're going to focus on our actual and our flex, because we hold, when we compare actual to flex, we take the actual volumes and we vary the price, hence price variance. So when we compare actual to flex, the overall flex, we are comparing the actual volumes, we're holding the actual volumes constant, and we're able to say, what was the impact of the change in price? So this is going to be revenue actual minus revenue flex, right? And in this case, that is 300 minus 200, 300 minus 200, which is a positive 100. And so again, because the only difference between these two is the change in prices. So that is our price variance. And notice we wind up 300 minus 200 is a positive 100. And that tells us that we were actually able to charge higher prices than we thought we were going to charge originally based on our expected prices. So we have volume variance of minus 225, which means we did less than we thought we were going to have. But we have price variance of plus 100, which means we were able to charge higher prices than we expected. When we add the two together, we have minus 125, because minus 225 plus 100 is minus 125. And notice that that matches back up to the higher level revenue variance, right? Because we said price variance plus volume variance has to equal revenue variance. So we calculated the price variance, the volume variance to be negative 225, and the price variance to be 100. When we add those two things together, we wind up with minus 125, which is equal to the original revenue variance. Okay. Now, they ask us to calculate the enrollment variance. What is enrollment variance going to tell us? Well, enrollment variance is going to tell us what the impact of the change in enrollment was on our revenue. So we know that our revenue, our overall revenue is down 125. What portion of that, what portion of the revenue is the result of being down in it or down in enrollment? Or what's the impact of enrollment on revenue? Well, the enrollment numbers are a kind of volume. So our revenue and utilization variances are going to have to roll up to equal our volume variance. Okay. So let me move that sheet up. So our enrollment variance, we're going to look for the two budgets that allow us to hold everything else constant but vary enrollment. So where are those? Okay, so we're going to hold, if we go to flex enrollment, we have expected price, expected utilization, and enrollment actual. And if we go to flex and overall flex or flex enrollment utilization, we have expected price, that matches, utilization actual, and versus utilization expected, enrollment actual, and enrollment expected. So that's not going to work. So we need to look for another one. So if we look at static budget, we hold price expected and price expected the same. Then if we look down in the volumes, we have utilization expected, enrollment expected, enrollment actual. Here's the pair that we want to use because everything else is held the same over here except for enrollment. That's where we're going to vary our enrollment, hence enrollment variance. So we're going to use revenue flex enrollment, which is this one, minus revenue static. So 180 minus 425, and that equals minus 245. Okay, so we had volume variance related to enrollment, right? Because enrollment is a kind of volume. So we had volume variance of minus 245 as a result of a change in enrollment. The other variance that we're going to work with is utilization variance, and that's the one I started to explain a second ago. Where do we hold utilization constant? Where do we allow utilization to vary and everything else stays constant? Well, that's these two, right? We have prices the same. We have enrollment is actual and actual, but utilization is actual and expected. So we want to have actual minus expected. So we're going to take 200 for the flex revenue minus 180 for the flex enrollment, and that generates a plus 20. If we add those two together, we get minus 225, which matches our overall volume variance. So enrollment variance and utilization variance simply decompose volume variance into the changes in the number of enrollees and the changes in the number of fee-for-service visits. So that decomposes into, we had a significant decrease. Most of our volume variance comes from the fact that we had fewer enrollees than we thought we would have, right? Because our expectation was we'd make 425. We actually made 180. So the big difference here comes from the change in enrollment. And then we actually did a little more, a few more fee-for-service visits that generated an extra 20,000 in revenues. So when you add that together, it's minus 225. Okay, so that is problem 8.2b. A little editorializing here. I think they could have done more with this in the chapter rather than just have it as a note. So hopefully that's useful and you get it a little better.